Hello everybody, this is our first session or video in JEE Mains previous year questions for chapter Ray Optics and Optical Instrument of class 12th. Before this video, in this series we have made several videos related to the other chapters, and all of those videos are available on our YouTube channel's playlist section. We have also started a similar series for NEET also. So if some of your friends are preparing for NEET, or if you want some additional practice, then you can watch those videos. And if you like this content, then do press the like button, share them as much as possible, and subscribe to our channel. And if you'd like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. Here is the first question on the screen. So when an object is kept at a distance of 30 centimeter from a concave mirror. So first let me adjust pen thickness. So we have a concave mirror here. Image is formed at a distance of 10 centimeter from the mirror if the object is moved with the speed of 9 centimeter. Speed of the image, which speed with which image moves at that instant is. So we have to find speed of the image. So for a mirror, we have relation that 1 by v plus 1 by u is equal to 1 by f. Now, if we take time derivative of these, what we will get? We will get minus of v raised to power minus 2 dv by dt minus u minus 2 du by dt is equal to 0, because focal length is constant for a lens. And from this we can get that dv by dt, that is the change in the location or position of the image with respect to time. That is basically velocity of image. It will be minus of v square by u square into du by dt, and du by dt is velocity of object. Now we know that v by u for a mirror, or negative v by u for u mirror, is a magnification. So we can say here that image speed will be equal to negative of m square, where m square is m is the magnification, into object speed. So let us find out the magnification, and as here we have magnification scale, so it does not matter whether our magnification will be negative or positive, we will take the modulus. So m modulus normal magnification for a mirror is equal to minus of v by u. Now here we have image at 10 centimeters, so this will be assuming 10 by 30, so it is minus 1 by 3. And we will not worry about the signs, that whether it is formed on the right side or on the left side, because we will get, finally we will get square of magnification. So it will be minus 1 by 9 into speed of the object, that is 9 centimeter per second. So we will get 1 centimeter per second, that is the speed of the image, or if we want it with proper sign, it will be negative 1 centimeter per second. Let us move ahead. A spherical mirror is obtained as shown in the figure from the hollow glass sphere. If object is positioned in front of the mirror, what is the nature and magnification of the mirror, of the image of the object? So here we can see that this is acting as a concave mirror, because we have reflecting surfaces on the right hand side, and object is placed at this point. Now this sphere diameter will be, this is 8, this is 4, so we have a difference of 4 here, 16, 12, 8, 4, so this will be 0. So we can say this distance, or we can say radius of this sphere, will be equal to 8 centimeter, and from that focal length will be r by 2, that will be 4 centimeter. So here distance between the mirror and the object is, that is 4, 8, and this will be further to 10. So u is minus 10 here. So we know in case of a concave mirror, if object is beyond is in the left side of the focus, then image will be real. Image will be real and diminished. And if it is real, then it will be inverted also. So if we match, then option D, oh sorry, not option D, it is inverted real and unmagnified, inverted real and magnified. So we will go with option A. So option A will be the right answer. Now let's move ahead. Concave mirror for face viewing has a focal length of 0.4 meter. The distance at which you hold the mirror from your face in order to see your image upright with the magnification of 5. So here magnification is equal to 5, and according to the requirement that image must be upright. So we can say this is positive magnification. So in case of a mirror, we know that magnification is equal to minus of V by U, and we have been given focal length and we have to find the distance, means we have to find the U. So from this we will get V is equal to minus of 5U. Now using the mirror formula, we have 1 by V plus 1 by U is equal to 1 by F. Now we will substitute here V as negative 5U, and here we will not take U as negative, because assume if this is our concave mirror, if this is our concave mirror and this is we can say focal distance. So as image is virtual, so means our object is somewhere between focus and the pole of the mirror. Now if we have some value regarding it, that suppose this is 5 centimeter, then U will be negative 5 centimeter. But if we are taking in terms of X, Y or Z, then we will not take, we will not add this extra negative sign. We will use it as it is. Only when we have numbers, we will add negative and positive signs. So here we will get minus 1 by minus of 5U plus 1 by U is equal to 1 by F, that is 0.4, or that will be 4 by 10. Now from this, now if we solve it, we will get 5U as LCM, and this will be minus 1, and this will give us 5 is equal to 5 by 2. From this side we will get 4 by 5U is equal to 5 by 2. So this will be 8 by 25 is equal to U. Now this is in meters because this focal length was in meter. So what we can do, we can calculate it in centimeter. So it will be 8 by 25 into 100. So that will give us 32 centimeter. And in meter it will be 0.32. So that is option C. So option C is right answer here. Let us move ahead. So here we have a point source of light S placed at a distance L in front of the center of plane mirror with width D, which is hanging vertically on a wall. A man walks in front of the mirror along a line parallel to the mirror at a distance 2L as shown below. The distance over which the man can see image of the light source in the mirror is. So we have to find out up to which distance on this line he can see the image. So let us adjust it slightly. Now as per mentioned here, that suppose this is the mirror and here it is the source, and here this is the line on which person is walking. Here person is walking. So we know for law of reflection that suppose there is a light going, let me draw it, that suppose light beam is going like this, then what will happen, it will get reflected, and after reflection it will go like this, and similarly from the lower half of the mirror, that after reflection it will go like this. And if we draw here this line, a normal. So we can easily say that if this angle is theta, then this angle will also be theta. Now we can calculate theta from here, that as this distance is L and this distance is what we have, that is d by 2, because total distance is d. So from this, if this angle is theta, then this angle will also be theta, and from this right angle triangle we can write that tangent of theta will be equal to d by 2l. Now if we extend it further here, and this distance is mentioned to be 2l, this distance is 2l. So suppose this is x here. So in this triangle, we can write that tangent of theta will be x by base, that is 2l. And here tangent of theta is d by 2l. So d by 2l is equal to x by 2l. And from this, x is equal to d. So now this is d, this is d, and this is also d. So up to total distance, he can view this image of the source will be 3D. That is option C here. So option C will be the right answer. Now let us move ahead. Two plane mirrors are inclined to each other such that a ray of light incident on the first mirror M1 and parallel to the second mirror is finally reflected from the second mirror M2 parallel to the first mirror M1. The angle between the mirrors is. So here we have two mirrors. So suppose this is our first mirror and this is our second mirror. Now they have some angle theta between them. So this angle is suppose theta. Now as mentioned that there is an incoming ray, and this is suppose M1 mirror and this is M2 mirror. So there is a inclined such that ray incident on the first mirror M1 and parallel to the second mirror M2. So okay, let us assume this is M2 and this is M1. So there is a ray hitting parallel on M1, parallel to M2 hitting on M1. So our ray will be like this. The ray is like this. This is the incoming ray. This is parallel to M2 initially. Then after reflection, what happens? It strikes to the second mirror, and after further reflection, it becomes parallel to the M1 mirror. So this is happening here. So this is like this, and it is like this, and here this is the direction. Now what we can do? We can draw normals. At this point we can draw normal, and at this point we can draw normal. Now as there is reflection happening, so we can say this angle, oh, okay, let me, this angle will be equal to this angle, and from that we can write that if this angle is phi, then this angle has to also be phi. Now it is mentioned that this line is parallel to this line. So if this angle is theta, then this angle is also theta. And again, as reflection is happening here, so if this angle is suppose alpha, then this angle is also going to be alpha. That means this angle is also going to be theta. So for phi, we can write that here phi will be 180 minus of 2 theta from this track. Now for this line, suppose this angle is beta and this angle will also be beta. For this straight line, we can write that phi plus beta plus phi should be equal to 180 degree. For this straight line, phi plus beta plus phi, it is equal to 180. And from this we know that theta, phi plus beta will be 90 degree, and for phi we will have 180 minus 2 theta. So this is 180 minus 2 theta plus beta is equal to 90, and from this beta minus 2 theta will be equal to minus of 90 degree, and from this we will have we can say 2 theta minus beta is equal to 90 degree. Now let us analyze another parallel line. Now as initially mentioned that this line, this initial incident ray is parallel to M2. So we can say now if I extend this mirror further and if I make a angle here, this angle will be 180 minus theta. So this angle will be going equal to this whole angle. So because both of these are parallel, so from that we will get 2 beta plus phi is equal to 180 minus of theta. So from this we can find the relation between, here we have theta and phi, and here we have 2 beta plus phi minus theta. It can be written like this: beta plus phi plus beta. We have written 2 beta as beta plus beta and is equal to 180 minus theta. Now beta plus phi, from here it is 90 degree. So 90 plus beta is equal to 180 minus theta, and from this beta will be equal to 90 minus theta. Substituting it here, we will get 2 theta minus of 90 plus of theta is equal to 90, and from this 3 theta will be equal to 180 degree and theta will be equal to 60 degree. So that is option B here. So option B is the right answer. Let us move ahead. An object is gradually moving away from focal point of a concave mirror along a axis of the mirror. The graphical representation of the magnitude of linear magnification versus distance of object from the mirror is correctly given by. Now, for a concave mirror, we know that it can produce both type of images, real images and virtual images, both type of images. And in the given options, if we can see here that magnification is always positive, so what we will do here, we will take only magnitude of magnification, so that will be V by U for the mirror. Now for mirror, we know for concave mirror that if object is between 0 and f, if object is between 0 and f, that we will have virtual image, and if it is beyond f, then it will be a real image. And we also know that at 2f, image is formed at 2f, so at 2f we can say magnification will be 1. So using this, if we see option A here, in option A magnification is unity at f, so option A is cancelled, and similarly in option B magnification is unity at f, so option B is cancelled. Now we have only option C and D left. Now in option C, if we can see here, let me zoom it slightly. We can see that here beyond f, between this, in this region between 0 and f, there is no value of magnification is given. And we know there is magnification also. Here we have positive magnification, and in this region beyond we have negative magnification. So this option might be wrong if we are taking both magnification. If we are taking both magnification, then it will be wrong. And if we are taking only positive negative magnification, then it might be right. Now, if we analyze the option D here, so in option D, we can see that here at F magnification is unity, which is not possible. So option D is also wrong. So the only option left, that is option C, and it means we are only taking negative magnification, and even taking magnitude of it, even only then we can represent that as a positive. So here option C will be the right answer. Now let us move to the next one. So a particle is oscillating on x-axis with an amplitude of 2 cm about point x node 10 cm with frequency omega. A concave mirror of focal length 5 cm is placed at the horizon. See figure. Identify the correct statement. The image executes periodic motion. The image executes non-periodic motion. The turning points of the image are asymmetric with respect to image at point x is equal to 10. The distance between turning points of the oscillation of the image is 100 by 21. So let us analyze this one. So as we can say here, object is oscillating with amplitude of 2 centimeter. So what will happen? The distance, minimum distance between object and mirror will be 8 centimeter and maximum distance will be 12 centimeter. So U will vary between 8 to 12 centimeter. Now, as object is at 12 centimeters, so it will form some image at some distance, and while it is means while u is changing, v also will changing, and when u changes its direction, v will also change its direction. So we can say that image will be periodic, or oscillation of image. Oscillation of image will be periodic in nature. Now what we will do, we will calculate the location of the image at both these values, when object is at 8 and when object is at 12. So initially, assuming we normally take object side as negative, so we will do the same here. And this is a mirror, so for mirror we have 1 by v plus 1 by u is equal to 1 by f. So here we will get that 1 by v is equal to 1 by f minus 1 by u. So focal length will be negative here, and image distance or object distance will also be negative, assuming this side as negative and this side as positive. So 1 by v, and this is 1. This is, we are calculating v1. So that will be equal to focal length that is mentioned as 5 centimeters. So minus 1 by 5. And here we will get negative of 1 by negative 12. And when we solve this, we will get v1 is equal to minus 8.57 centimeter. Now similarly for v2, we can write 1 by v2 is equal to 1 by f2 minus, f will remain the same, 1 by u2. Now this will be negative 1 by 5 minus of minus 8. And when we solve this, we will get v2 is equal to 13.33 in negative sign. So now it is asked that it is asymmetric with respect to the point x is equal to 10. So to find whether it is symmetric or not, what we will do, we will find the distance between 10 and this value, and 10 and this value. This is negative 13.33. And to do that, what we will take magnitude only. So we can say delta x1 will be 10 minus 8.57. We are taking only magnitude, and this is equal to 1.43, and delta x2 will be equal to 10 minus 13.33, and we will again also take the magnitude, because we are only interested in magnitude, that whether magnitude is equal or not, and this is 3.33 centimeter. So we can see that if this is x is equal to 10, so on the one side image is from this image distance is 1.43, and on the other side this is 3.33. So image formation is not symmetric about this point. So that is mentioned that turning point of the image are asymmetric. So option C is also right here, option A is already right. And now coming to the D also, and B will be wrong as A is right. That distance between the turning points is 100 by 21 centimeters. So distance between the turning points will be 3.33 plus 1.43, that is 4.76. And if we divide 100 by 21, we will get 4.76. So these are the exact matches. So option D is also right here. So we have to find the correct statements, and that are A, C, D. So that is option C. So option C is correct here. Now let us move ahead. You are asked to design a shaving mirror assuming that person keeps it 10 centimeter from his face and views a magnified image of the face at a closest comfortable distance of 25 centimeter. The radius of the curvature of the mirror is. So here value of u is going to be minus 10 centimeter and value of v is going to be again 15 centimeter. And why we are taking v is equal to 15 centimeter, where it is mentioned that this image is formed at a distance of 25 centimeters. So what will happen here, that assuming we are making we are taking a concave mirror here or any type of mirror, so a person is seeing himself. So the distance of the object, that is 10 centimeter, is also the distance of the person and is also the distance of his eye. So if as mentioned here, that image formed is at a 25 centimeter from the eye. So either this image can be formed on this side or this image can be formed on this side. And if this distance is 25 centimeter and if this distance is 25 centimeter, we already know that this distance is 10 centimeter. So, and while we take v, it is the distance from the lens pole. So this distance will be 15 centimeter. So that's why we take it as 15 centimeter. So, and normally a person cannot see backward. So that's why this case where image is formed behind the person is not possible. That's why we are taking only this case. So here we can use now mirror formula, that 1 by v is equal to 1 by u plus 1 by f. Now 1 by v will be 1 by 15 minus 1 by 10 will give us 1 by f, and from this we will get f is equal to minus of 30 centimeter, and from that further we will get that radius of curvature is twice of the f, that will be minus of 60 centimeter, and that is option C here. Let us move ahead. A car is fitted with convex side view mirror of focal length 20 centimeter. A second car 2.8 meter behind the first car is overtaking the first car with a relative speed of 15 meter per second. The speed of the image of the second car as seen from the mirror of the first one is. Now we have a mirror formula, that 1 by v is equal to 1 by v plus 1 by u is equal to 1 by f. And from this formula, while taking derivative, we can write 1 by v square into dv by dt minus 1 by u square du by dt is equal to 0. And this is image speed, this is object speed. So we have a relation that image speed is equal to negative m square of object speed. So we have to find out basically image speed. So if object speed is given to us, that is 15 meter per second, and we have to find magnification. So magnification can be found out using again this relation, and which I have already written, that from this we will get 1 by v minus 1 by 280. Why 280? Because we are taking in centimeter, because focal length is also in centimeter, is equal to 1 by 20, and this will be negative because we have it will be positive because we have a convex side view mirror. So from this 1 by v will be equal to 1 by 20 plus 1 by 280. This will be LCM 280, and we will get 14 here, we will get 1 here, and v will be equal to 280 by 15. Now magnification will be minus of v by u. So 280 by 15 divided by u, that is also 280. So this will be minus 1 by 15. Now substituting it here, we will get negative of 1 by 15 square into object speed, that is 15, or this is negative 1 by 15. So negative sign as it is, and we will get 1 by 15 meter per second as answer. So that is option C. Sorry, not C. Option A for us. So option A is the right one here. Now, with this, let's end today's video here. Hopefully, you understood whatever we have covered here till now. And if you have any doubts or suggestion, you can put them in comment section. And if you like this video, then do share it, subscribe to our channel. And if you like to donate us something, you can scan these QR codes in front of your screen. With this, again, thanks for watching, and we will meet in next video.